not only are we able to translate our graphs horizontally and vertically, we're also able to stretch and compress them. And we're going to talk specifically about vertical stretches and compressions and vertical reflections. So let's remind ourselves again of some parent functions, right? These are the most basic forms of functions. So if I were to graph y equals the absolute value of x, which is a super basic graph, looks like that, and then I were to graph 5 times the absolute value of x, what would happen is it would be the same graph, but it would be stretched out taller. It's 5 times as tall, right? So instead of when I plug in on the parent graph, when I plug in 1, I get 1. On my child graph, when I plug in 1, I get 5. So it's 5 times as tall. So it's skinnier, so it looks smaller here, but it's actually just really tall. Same thing, so that would be this one. Now let me try in red. 1/2, it's going to be shorter. It's going to look fatter, but it's really just shorter. So if you notice this, the leading coefficient, right, the number out front, this number affects the vertical stretch or compression. Okay, so here's the key idea. It does not matter if this is a positive or negative number. We only are paying attention to the actual number, okay? So if I have negative 5x squared versus 5x squared, the negative is going to do something different. All we're looking at is this. These are both stretched by 5, okay? So for example, if the number is bigger than 1, it's going to stretch and get taller and skinnier. But if the a value, that's what we call that, or the coefficient is less than 1, then it compresses shorter and it gets fatter. So what if the number is negative? Let's go ahead and look at what that might look like. So let's graph that same absolute value of x. If I plugged it into Desmos and I put a negative, what it would happen is it would reflect. Negative 5 of x would get skinnier and taller, but also would be upside down. So we can see that a negative a value means a vertical reflection. Okay? Again, the negative doesn't mean that this is going to make it flatter. It still makes it taller. The negative just flips it upside down. Okay, so you can see here kind of the main ideas here. If a is greater than 1, then it's going to stretch. If a is between 0 and 1, right, it's going to compress. Now, this is the one we don't really look at. I want you to just focus on this. It'll reflect over the x-axis, which means it's going to reflect up and down, because this is our x-axis right here. All right, so let's try some examples. I'm going to skip the parent function part. I think that's pretty basic. Hopefully you guys can get that. Transformations. This is going to stretch by a factor of 6. Usually we say by factor of, right? This is going to stretch by a factor of 5, and then it's going to go left 2. So you can see there's 2 different transformations here. This is going to compress, right? It's getting shorter and fatter by a factor of 1/3. So it's 1/3 the height. This is going to stretch by a factor of 2, and then it's going to go left 6. So you can kind of see it's just the same thing every time. This negative is going to be a vertical reflection. And then this guy is going to make it go right 2. And again, the parent function is x cubed, so you're not really worried about that 3 there. All right, since this number is less than 1, it's going to be a compression by a factor of 2/3. And then it's also going to go up 1. Here it's going to be a stretch by 6. And it's going to go down 1. This one has a lot. Look, there's 1, 2, 3, 4 transformations. I'm going to do it in a different color to make it obvious. It's going to have a vertical reflection. That's what that negative is. That 5 is going to be a stretch by 5 vertically. The 2 is going to make it go left 2. And then the negative 7 is going to make it go down 7. All right, we can skip these last two. I think you get the point. So write an equation of a function whose parent is this, but it's shifted 4 units left and 3 units up. It's also reflected. So we're going to have a negative out front, because that's going to be the reflection. It's going to go 4 units left. So I'm going to get an x plus 4, and then 3 units up. And that is my final answer. What about an x squared? So something squared. It's been shifted right 2 units. So I'm going to do x, oops. I'm going to do x minus 2, 1 unit down, stretched vertically by 3. So I'm going to put 3 out front, 3 times all of that. And that's my final answer. X cubed, but it's been compressed horizontally or vertically by 1/2. All that means is I multiply it by 1/2. Write the equation of the square root function, which is just this, that has translated 3 units down and stretched vertically. Well, we don't know why. By what? So let's stretch it by 4. So I might put 4 radical x and then shift down 3. All right. Last one, describe the transformation. This is going to be a stretch by 6.7. This is going to go left 3. This is going to go down 7. This one is a reflection. Again, that 1 won't do anything because a 1 doesn't change our graph. And this is going to go up 6. So that is reflections and vertical stretches and compressions. And that's it.